Hello, I'm Julieta Padilla Campos, and in this video I will be talking about the infinite square world problem in quantum mechanics. 1. Eigenvalue problem stability. How do the calculated energy levels change with the number of discretization points? The energy levels equation was used to calculate this. The variable of n was the one that changed 5 times, as we can see in this image. And discretization means in how many pieces the well will be divided. So the higher the value, the more precise the result will be. 2. Orthogonality of eigenvectors. Are the computed wave functions eigenvectors orthogonal to each other? We have to verify this because in quantum mechanics there is a property that says that the vectors have to be orthogonal to each other in the Hamiltonian vector space. So to do this, we used a MATLAB code to compute these calculations. So we know that two vectors are orthogonal to each other if their dot product is 0 or close to 0. And as we can see in this image, the values calculated by MATLAB say that these vectors are orthogonal to each other because the values are really small, which means they are close to 0. 3. Influence of effective mass. How do the energy levels change if the effective mass of the particle varies? In quantum mechanics, the energy level is modified by the effective mass of a particle, in this case the semiconductor material. Here we used 3 different semiconductors, which were germanium, silicon, and gallium arsenide, and we made a plot in MATLAB to see how these values of the energy levels change. As we can see in the image, the effective mass is inversely proportional to the energy level. The higher the value for the effective mass, the lower the energy level, and vice versa. 4. Comparison with theoretical values. How close are the computed energy levels to the theoretical values for an infinite square well? In this case, the theoretical values have a minimum absolute error in comparison with the numerical method values. We can see this by analyzing the values computed by the MATLAB code. Here we have the energy levels by the numerical method, the theoretical energy levels, and their respective absolute error for each one of them. 5. Impact of the well width on energy levels. How do the energy levels of the particle change as the width of the infinite square well is varied? The MATLAB code was used to in this case in order to plot the results by changing the width of the well. By analyzing this image, we can see that the higher the width of the well, the lower the energy level will be. Therefore, the relationship between the well width and the energy levels is that they are inversely proportional, since when one increases, the other one decreases. 6. Matrix representation from discretization. Use the Schrödinger equation to make a matrix representation from discretization. Here, the Schrödinger equation has a relation with the eigenvector equation, in which the wave function variable is equal to the eigenvectors, E is equal to the eigenvalues, and H is equal to the Hamiltonian matrix. To create the Hamiltonian matrix, the discretization process uses the finite difference equation in order to get the system of equations. As we can see in the matrix displayed by the MATLAB code, the final result is a 3-diagonal matrix, which means that the main diagonal has the same value. The super diagonals, which are the upper and lower diagonals, have another value, and then the rest of the values are all equal to 0. So with this video, we can demonstrate that there is a relationship between the quantum mechanics and the linear algebra.